Now, I've also got Adrian with me today. Adrian from Container Solutions. Adrian, do you want to say hi?
Hi there.
Adrian has come in to share some industry gossip with us. Now, Adrian, what's been on your mind recently?
I thought we had slides.
No, we do have slides. Don't give the gossip now. Don't do the gossip now, for goodness sake.
Oh, you just said what's on my mind.
Yeah, but I didn't mean the gossip bit. I'm more like, how are you doing? How's your week been?
No, I'm good. Yeah, I've just been working away and trying not to shake the news every 5 minutes.
It's been a bit addictive, the news. It's been a bit addictive. I'm old enough to remember Al Gore and George W. Bush, so I was not surprised this week. Okay, let's get cracking then. So, my name's Jamie. I'm from Container Solutions. I'm the CEO and the founder, but I love to get involved in all of our community work. When COVID kicked off, we were kind of too tired and too fed up to filter ourselves, and some mad person had the idea to create a content campaign called WTF Cloud Native. What the fuck is Cloud Native? Now, I swear a lot, but even I am sick of all the bad language that's been going around our office for the last couple of weeks. WTF is meant to bring the community together. If you'd like to talk about something, be a guest blogger or join us on a webinar, we will help, we will facilitate. It's meant to get a conversation going. Of course, we're a company, but WTF is really 90 or 95% about engagement, and maybe it's 5% about sales, but we'll be doing absolutely no sales today. It's about the community, about bringing everybody together. And of course, when we talk about the global community, we don't just mean the Western countries of Europe and the US and Australia, but also we're doing work to do outreach into emerging economies too. So we're really trying to take Cloud Native to a global audience. You can subscribe by following the link that Carla is going to pop into the chat box. Alternatively, just keep coming back or follow us on Twitter, then you don't get any spammy marketing emails, but you can always join the events. We've got some really cool events coming up. Next week, Penny will be talking about what is Cloud Native and actually why should I care. If you go over to the blog, right now, you'll see a few things. You'll see that Cloud Native is contributing to jobless recoveries. And we're in a massive recession now. You'll also see that we've got some opinions on data centers and their effects on the environment. So you should care about Cloud Native because it's changing our society, and you should care about it if you work in tech because it can fundamentally improve the way you deliver values to your customers. Now, straight after that, I'm teaming up with Matthew Skelton. He wrote Team Topologies. I've got massive envy because I wrote a book too called Cloud Native Transformation Path, and I've got like 3 reviews on Amazon, and Matthew has got about 500. Actually, Sam, Sam's got the book. That's Matthew's book. Thank you, Sam. Now, I'll just bring you in there, Sam. How many stars have you got on Amazon?
I lost count after the first ever review I saw. My book was 1 star, not enough Ruby code samples. And it's like, I didn't write a book about Ruby. There's no Ruby code samples in it. So I can't really argue with the review, but yeah. I thought 1 star, that's enough review looking for me. So I don't actually look at them anymore.
That's it. Your self-esteem was shattered for forever and never to return. Now, isn't it true that your book was the best-selling O'Reilly book ever?
No, I'm 100% sure that that's not true. Like I suspect I was the bestseller for a year or 2, I think.
Yeah.
But I'm pretty sure Martin Kleppmann's building data intensive applications is probably now outsold building microservices, which is why I'm now going for quantity over quality. I'm just writing more books to try and outcompete Martin, even though he's smarter than I am. If I can get more done, I will eventually surpass him.
Exactly. That's the Jamie Dobson way. Whatever you lack in talent, you make up for in effort. That's the way forward. Okay, good. So you can join me and Matthew. We're gonna have a screen with this one. Now, Carla's gonna do a poll. What are Cloud Native patterns and what is Cloud Native transformation? These are 2 topics that our audience really care about. Let us know which one you want us to do next, and we will put that together for December. Okay. Now, finally, we get to our feature, what is the gossip? And this is where I would like to bring in some of our guests. So, I forgot to put your thing there, Bill. So first of all, some of you will notice that D2IQ has gone full Kubernetes. Now, Adrian, I want to get your opinion on this. What do you think about that?
Yeah, I wasn't expecting you to ask me about that one. I think it makes sense. Like everybody was moving towards Kubernetes, I guess, all their clients were as well. So it's a shame, but
to me, this felt like the very final moment when Kubernetes won the orchestration battle. There really doesn't seem to be much of an alternative, right?
Well, I guess Nomad would, the HashiCorp guys would disagree with you there. But yeah, I mean, Mesos, at the time back then, you're talking about Docker Swarm or Swarm mode, and Mesos and Nomad. And okay, we could already see Kubernetes was in the lead, but it wasn't obvious that it was going to absolutely crush everybody to the extent that it did.
Yeah.
But yeah, it did.
And you've been talking over at Container Solutions about Docker and rate limiting. Do you want to give us an update on that?
Yeah, so I think that's worth talking about, especially in case anybody's not heard about the changes that have happened. So there's two parts to this. Docker, back in August, they announced that this was going to happen. And there's two parts. Retention policy is like about deleting of images. So currently the Docker Hub stores 15 petabytes. And I mean peta, P-E-T-A, petabytes of data. And it turns out 10 petabytes is basically completely unused. And it represents images that haven't been pushed or pulled in 6 months. So they want to basically delete that. But that change has been pushed out to the middle of next year. I think the main reason is they want to give people more of an opportunity to figure out what data they're going to lose, and also build out some more sort of dashboards and CLI support.
Yeah.
And the Docker rate limiting is much more important, and that got turned on this week. So basically, the rule is that every 6 hours, if you're an unauthenticated user, you can only pull 100 times. So that you can only do a Docker process. It's at the client end. It's not at the server end.
Do you expect a backlash from this?
Well, you can go on Twitter. There's certainly people talking about it, but I mean, it's just a money thing. Like the Docker Hub, since the enterprise split, like the Docker Hub basically used to support the way Docker used to make money was via the enterprise products.
Yeah.
Now they sold that off. They need to rethink things and try and figure out how to make money with the Docker Hub and developer tool, which I think is actually a healthier proposition. But that now means that the Docker Hub can't be making a huge loss.
Yeah, absolutely. Okay, so thank you for that, Adrian.
Well, do let me finish, if it's all right, just because I do think it's a kind of important point. So the rate limiting is going to hit you probably not as an individual developer on a laptop, but if you're on a large office on a NAT and everybody's doing anonymous pools, you get hit then. If you've got a large cluster, the large cluster is probably all going to be behind the same NAT effectively. And so the Docker Hub is going to see that all as one user, and you're potentially going to get rate limited. The other place is CI/CD. I believe some of the CI/CD platforms have put agreements in place with Docker, so you might not get hit there. But if you do start seeing issues with pools in your cluster, it may well be this. A solution is either to start paying the Docker Hub. So if you pay the Docker Hub, you don't hit these limits, or to set up like a proxy cache or something like that. And if you go, I think we're dropping some links in, and I'll give you more details on some of the sort of solutions you can look at to solve this problem if you get it. Sorry, back to you.
Very cool. Thank you for that, Adrian. So the other thing you can ask, Adrian is the creator of the Trowel Docker registry. Is that have I described that properly, Adrian?
Yeah, that's fine.
Adrian knows a lot of stuff about this. So Carla, can you please share our public Slack channel? You can speak to Adrian directly in that Slack channel, or to me. Please don't abuse him. That's my job. Thank you for that. Now, finally, let's talk about the CNCF. So Andy Randall, our friend from Berlin, he is agitating to get the CNCF re-headquartered to Europe, potentially Brussels. Now, I don't know how serious he is, but Carla will share the link on Twitter, which if you want to join that debate. However, I'd like to now bring in Bill Mulligan, who's got a few words to say about his initiative, and then this will be the final piece of gossip before we move on to the main bulk of the content, which is Sam talking about microservices. Bill, take it away.
Yeah, sure. So unfortunately, as a CNCF employee, I can't comment officially on whether the CNCF is moving to Europe. But one initiative that I can comment on that I'm actually super excited about is what we're going to be launching at KubeCon. And what we're going to be doing actually really ties really nicely into what we're talking about today. And what we're going to be doing is launching a conformance initiative around the definition of cloud native for applications, specifically in the telco space. And so if you aren't familiar with the telco space, they go from copper wires all the way up to running microservices in cloud native architectures. And the biggest problem that they have is a lot of this legacy infrastructure. And the question is, how can they modernize it? And when they're building new greenfield applications, how can they make sure that they're building it in a cloud native way? And so what we're going to do to kind of help out the telco industry, and actually really a lot of people more broadly, is understand what cloud native means for telecommunications workloads, and also like applications also in general too. And so what we're actually building out right now is actually similar to the Kubernetes conformance working group. So if you're familiar with that, the the Kubernetes conformance like badging lets you go and self-test whether your Kubernetes cluster that you built is actually Kubernetes. And so what we're going to be building is something similar, where there's a CNF work group that kind of defines what cloud native is for application. And then there's a test suite that kind of goes and implements tests that you can run against your application to see if it actually is built in a cloud native way. And so tying into the topic of today, one of those tests is going to be microservices based. So if you see the rest of the webinar today, hopefully in the CNF test suite, you can go download and see if what you learned today, you can actually implement in your applications.
Very
and
cool.
So,
and
yeah.
So if people want to find out more about that, they can follow the links in the chat box, or they can follow you on Twitter or reach out to you directly.
Yep, exactly.
So if anybody needs an introduction to Bill, I can facilitate that. You can also find him on social media. I think that's a great initiative. Telcos it's like we work with a lot of telcos, and it's a thorny issue, but it's good for us to see that this is finally starting to emerge. Okay, so thank you, everybody. Now, give us some feedback if you've enjoyed this section, if you like the industry gossip and the banter. This is the format we're going to try to use. If you think it's complete rubbish, please let us know, and we'll adapt, and we'll make sure that we are more engaging and entertaining next time. But for now, thank you for letting me speak. Thank you for letting me share. And without any further ado, I'm going to hand over to a legend of the distributed systems world, and my friend, Sam Newman.
Thanks, Jamie. I'm a legend of the buzzwordy compliance marketing world of microservices. I think, there are legends of distributed systems. I don't class myself amongst those people in any way, shape or form. I'm going to do like a short presentation. We're talking like 15, 20 minutes just to say, here's what microservices are, at least, based on what Sam thinks. And obviously you're out there entitled to your own opinions, but in which case you should write your own books. So I'm going to share with you what I think these things are, and then we can have a conversation. So I'm very happy for you to ask questions afterwards, and we can go through it in detail. And I am especially happy to be called on my bullshit. So that's what keeps me, that's why I'm hanging out with Jamie, because that makes sure that it really happens on a frequent basis. I need to be leveled off an awful lot, because I do have an ego quite sizable. Right, so let's go on with the presentation.
Sam, just let me pause you for 1 second. If you've got questions, please put them in the chat box, and I will filter them and make sure they get asked at the end. However, you can also speak up, so you can unmute yourself and come into the questions after Sam's talk. Switch your cameras on. We'll be lovely to see you, and be lovely to hear from you. Okay, Sam, go.
Awesome. Cheers, Jamie. Right. Let's make sure I'm sharing the right screen. I don't want to share my email client again. Here we go. Fantastic. So what the fuck are microservices? I apologize for swearing, but Jamie started it. So really quick bit of background. I wrote a book about microservices. The reason I got interested in microservices, I think this is kind of really important for understanding the mindset behind how I talk about them. And I think a lot of the reason people are excited about them, or certainly maybe were in the past excited about them, was I got interested in microservices because I was focusing on this area of kind of continuous delivery, right? How do you get software into production as quickly as possible? And I realized that, you need to do all those things around build automation, test automation, moving to the cloud. All of these are things that can absolutely help. But often the system architecture meant that you weren't able to get the software out the door as quickly and as safely as you might like. So this is why I got interested in different types of system architecture that would make kind of fast, efficient delivery of software possible. So I wrote this book, I started it in 2014, released early 2015. I'm working on a second edition at the moment. That will be out middle of next year. And I now run my own company doing training advisory work, but you can find information over my website. And I've just also written a new book, that came out end of last year now, which feels like either a month ago or several years ago, called Monitor Microservices. And that's really a book that most people don't start with a microservice architecture. In fact, I don't think most people should start with a microservice architecture. I think it's much more sane and rational to kind of stick with a simpler deployment topology that, as you understand the constraints, you then work out how you might want to break that apart later on. I think that's a rational way to go about it. And so there are lots of you out there, I know, that have an existing system and you're thinking, well, I want to try out microservices. How do I take what I've got now and move towards that architecture? So this particular book that was out at the end of last year is all about that process. I have a whole chapter just on how you break databases apart, right? Because it turns out that kind of stuff is really annoying. So more information there if you want it. But we're really here to talk about what microservices are and pictures. I like pictures. I'm a visual thinker. So here we are, we have our kind of our hexagons. I draw them as hexagons for a bunch of reasons, but partly it's a nice shape. Partly I draw microservices as hexagons because it's a reference to an earlier kind of architectural pattern called hexagonal architecture. Also, it's nice to actually have a sort of a different way of denoting a microservice versus other types of services that you might have. We'll talk a little bit about maybe what makes them different in a minute. And this is it. So hexagons, talking to other hexagons, but they've got names: shipping, inventory, accounts, returns. With microservice architectures, we're primarily thinking about end-to-end slices of functionality that, yes, in some cases should include the UI. We're not talking about layered architectures here that really talk about, you know, just groupings of technical functionality. We're looking for services here which are grouped around sort of business functionality, around business capabilities, and all that rubbish about bimodal IT and paste layered architecture should be completely ignored because it's rubbish. This is what you want, right? You want kind of things that are structured more around your business, your product development. We'll come back to that interplay between architecture and organizational structure in a minute. One of the key things we think about with microservice architectures, and in fact, the key thing we're looking for with a microservice architecture, is this property of independent deployability. And look, we can kind of put all of the other stuff to microservices off to one side, really, and focus on this idea: independent deployability, the ability for you to go and make a change to a piece of your software and deploy that change independent of anything else needing to change in the wider system. So in a microservice architecture, because our microservices are deployed as separate processes, we theoretically have this capability, right? So in this example here, I want to make a change to the shipping microservice. I should be able to go in, make that change to update some functionality, roll out some new features, whatever else it might be, and deploy a new version of that into a production environment, release that functionality to the users of my software without having to change anything else. And fundamentally, this is what makes microservices interesting, because this allows you to kind of think about increasing the degree of autonomy within your organization. I can now make changes in isolation and roll those changes out independently. This really, when you get down to it, is all about reducing kind of coordination and contention in your systems architecture. Now, independent deployability, simple idea: make a change, just deploy that thing by itself. And it's not just the idea that you can theoretically do that, but it's the idea that you actually do that as part of your software development. Now, obviously, there are other things that we'd need to talk about how you make independent deployability happen. It's not just in terms of how we find our service boundaries. It's not just in terms of the communication protocols we might pick, but it's also in terms of the development behaviors and your organizational structures. And we'll come back to some of those ideas in a minute. But just if there's only one thing you take away from my talk today, it's like, please buy my books because there's a lockdown and I've got to pay my mortgage. But the second thing should be that microservices are about independent deployability. And if you get independent deployability working, the likelihood is you've probably also done a whole load of other really clever stuff that you should do anyway. So kind of making that your focal point can drive a lot of good behaviors. If we zoom in and look at a microservice in isolation for a moment, look at it maybe from more of a technical aspect. When we think about a microservice, it's typically we package a microservice instance as a process, right? And that's normally how we deploy a microservice. It's like, so all the code associated with the given microservice instance is packaged together in a process, and we might deploy that process onto physical hardware, a virtual machine, a container, and maybe even a function platform, like a fast platform like AWS Lambda or Azure Cloud Functions. And there the concept of process gets a little bit interesting, but fundamentally that's what we might do. Now, obviously we might have multiple copies of these processes. So I might have multiple instances of my shipping microservice in order to serve additional load or to introduce additional robustness of my system so that I can tolerate failure of nodes. And obviously, you know, this is the kind of area where platforms like Kubernetes can be helpful in terms of managing that. The communication between these microservices is handled via some kind of network call. When you sort of draw a diagram like that, those arrows represent some form of dependency. So in this example here, I've got that shipping microservice is talking to, it has a dependency on the customer service. It also has a dependency on the inventory microservice. And this is this fundamental challenge in a way. Microservices exist to be called, right? A microservice that doesn't get called and doesn't call anything else isn't really a microservice. It's kind of just a separate standalone application. And if you can build your system like that, fantastic, you do it. But we do have this then interesting tension between microservices collaborating with one another, but also being able to be independently changed. And that's a really kind of, that's one of those tricky balances that you're going to be dealing with. How do I allow microservices to communicate without becoming coupled to each other? Exactly how this dependency is implemented can vary. This could represent a request response call, for example, like a REST over HTTP call or a gRPC call. So the shipping service could be actually going to the inventory service and asking it to do something, or saying, give me some data. But this could also represent, say, something like an event broadcast mechanism. For example, my inventory microservice might be emitting events, and my shipping microservice is subscribing and reacting to those events. You know, logically speaking, though, the dependency here is that the shipping microservice depends on something the inventory microservice is doing. So there's loads of different communication protocols that you could pick, and we can talk about those if you want. So don't get het up and thinking, oh, I have to do REST over HTTP, or, oh, I have to do, you know, asynchronous request response or whatever else. There is a lot of, I think, dogma out here in this space. If you look at something like the Reactive Manifesto, for example, I know the authors of the Reactive Manifesto, and I think they're very smart people, but they're very dogmatic about this aspect of systems architecture, which I don't think is overly helpful. Happy to have that conversation, though, if you want. One of those areas where microservices start getting quite tricky for people to comprehend or understand how that would work is this idea that we hide data inside a microservice boundary. And this is all about making independent deployability possible. This causes us issues, though. So in this example here, the shipping microservice, all the instances of the shipping microservice will manage its data by talking to its own database. So this would be a logically isolated set of data storage. We're avoiding the shared database. We can come back to that later. So what we're looking for here is the idea that when we've got a feature that wants to be rolled out, that we're increasing the chances that that feature that wants to be changed is only going to impact a subset of our system, allowing us to roll out that change effectively. So we're trying to come up with the boundaries for our microservices in a way in which we kind of decrease the chances of cross-cutting feature changes happening. And this, again, is why layered architectures are so problematic, because, you know, frequently with layered architectures, you find yourself having to make changes across those layers. And we kind of recognize that with microservices and say, well, actually, well, then rather than slicing systems sort of horizontally, we look to instead slice things. Rather than slice them horizontally, we look to slice things vertically, because we increase the chances that features are going to be able to be rolled out by a single team. And again, this interplay between architecture and organizational structure comes up. We often compare the microservice architecture with the monolithic architecture, and monolithic architectures come in different shapes and sizes. Probably the most common one you're thinking of would be the sort of single process monolithic application. I talk about a monolith as being a unit of deployment. So in other words, it doesn't matter exactly what the architecture of that monolith is, but if I want to roll out a single small change, I still have to redeploy the entire monolithic application. And don't get me wrong, actually monoliths can be a completely sensible choice. And in fact, I think it's our sensible default choice for a systems architecture. If you don't know what kind of systems architecture you want, or you're building something brand new, you should probably start with all of your code packaged up into a single process, talking to a single database. And that's a good starting point for most people. But over time, as you grow, as you scale, especially as you add more developers, that will become a bit of a constraint in terms of how quickly you can get things done. Now, there are lots of smart people out there that have kind of put their thinking hats on in terms of, and given us lots of the information that we build upon in the area of microservices. But probably the earliest person that was sort of thinking about this in a big way was a friend and colleague of mine, James Lewis. He's an old colleague of mine from ThoughtWorks, and, probably arguably came up with the term microservices as well. And he has this great quote, which is that microservices buy you options. And it kind of, this is kind of the key to me. People like microservices because of the options, right? We love having options. We love having optionality. We don't like being painted into a corner. We like to think that we've got like about 10 or 15 different ways we can solve any given problem. And yes, there is the tyranny of choice in all of that, but there is a nice idea. We're always going to have a way to think ourselves out of a problem we're in, or solve problems in different ways. And we like having a load of different choices at our hands, and microservices absolutely give us that. But that quote is worth going over again, right? Microservices buy you options. There is a cost to doing this. Microservices have a cost, okay? And those costs can be significant. And that's always why, when I'm working with clients, it's like, if you're thinking about doing microservices, it's very hard to kind of do a cost benefit analysis when you start saying, okay, well, we'll take our monolithic system, we'll have 400 microservices. Should we do that? And it's like, no, you should probably start with one microservice and let's find out how it goes. Let's understand what the cost of microservices are to you, and then work out if you're getting enough benefit out of that. Fundamentally, we have to deal with the fact that microservices are a type of distributed system. The more fine-grained your architecture becomes, the more distributed it becomes. And distributed systems are hard. Kubernetes does not fix distributed systems. It doesn't. It handles the, how do I run lots of containers on lots of different machines problem? And it does it pretty well, right? But that doesn't solve the fundamental properties of the physical universe, for example. Distributed system stuff is difficult. Now, most of you, even if you kind of say, I've only ever built a single process monolithic application, have to some extent built a distributed system. A distributed system technically is one where you've got two computers communicating over a non-local network. And so most of us have built things like that. Think about a situation where your application pulls data from a database that's on a separate machine. That's technically speaking a distributed system, but it's a really, really simple one. And it's much easier to sidestep a lot of the challenges in this space. There are horrible, horrible things that happen when you build distributed systems. And if you are new to this space, maybe you covered this at university, right? You may remember dimly some of the conversations about harvest and yield and all this sort of stuff. You might have been fortunate enough to have some of that in your education, in your past, but it's probably not being your current present. So there's going to be a lot of new things that you're going to have to get your head around. I mean, there's basic things like, latency. We're adding network hops. Is that going to make your application slower? We've got issues now about how we get data around our system. If I want to improve the latency of a distributed system, a common way of doing that is to do things like caching of data. But if I'm caching data to make my systems faster, I'm then dealing with the fact that my data that I'm working with is now potentially inconsistent. So how do I operate on stale information? At this point, a lot of people start saying, well, that's okay, I'll use distributed transactions to solve this problem. And then you've got even more issues going on. And then we consider lovely things like partitions. So partitions are things which occur where one part of your distributed system can't see another part of your distributed system. And guess what? A lot of those are going to be outside of your control. You will sometimes have situations where a call to another microservice just doesn't work. It's not necessarily your fault. It's just what happens. You have to build that thinking into how you design your system. Kubernetes can spin up another node if one dies. It can't solve what happens when this service is unavailable for you. That is something you're going to have to build into the thinking of your application. When I can't check the inventory I've got for my e-commerce site, what do? Do I just shut the whole company down? Or do I work around it in some way, shape, or form? That is still thinking that's on you. So All of these are properties which mean you're going to have to think differently about your system's architecture. And applying lots of conscious thought is really important to this. Look, microservices, our hope, right, is that they can justify their cost if they give us other things in return. So if they open up other possibilities in terms of how we scale our applications or improving our autonomy. And this is why a lot of organizations are adopting microservices, especially those organizations which are like scale-ups, larger enterprise organizations, especially. Their attraction towards microservices is largely being driven by the promise that they can have a lot more people working on a problem in a more efficient manner. If you've got 200 developers all trying to fight over the same thing and the same code base, and you've got, you're constantly having to coordinate between all of those people and coordinate between all of those teams, it becomes a nightmare. With a microservice architecture, if we align that with an organizational structure that supports it, we can hopefully reduce the need for coordination between things. With our monolithic application, if I've got loads of different teams, they're all sort of fighting over that monolith. We're also, well, I need to get this change done. Oh, no, you can't do that. I'm trying to do this. And what does this coordination look like when it plays out in the real world? It's meetings, isn't it? Lots more meetings. It's release planning exercises. Typically in environments where you've got multiple people all trying to kind of change the same system at the same time, you end up having full-time release managers. You're getting merge conflicts. You're getting bugs in your software. And the more you have to constantly coordinate between people, the slower you get. So I've got a cup of coffee here. Now, I could go to all 100 or so of you and say, can I drink this coffee? And probably by the time I've got back a confirmation from all of you that, yes, I can drink my coffee, that's great. We're all on the same page. Sam can drink his coffee. Guess what? By the time I get that confirmation from all of you, the coffee's going to be cold. Coordination takes time. Getting people's buy-in takes time. That slows you down. And if time to market is your most pressing concern, this is an issue. We also understand this in terms of trying to avoid siloing, right? I don't want to have to wait for somebody else to do something before I can carry on my job, because that handoff creates inventories and wait states. Screw agile, just think about lean and lean manufacturing. It's all about avoiding handoffs to go faster. So what we're looking for with our microservice architecture, in terms of taking an architecture which theoretically allows us to make changes independently, is actually aligning that with an organizational structure that does the same. So the most common model and the most sensible model to get the most out of microservice architectures is one where a team owns microservices, or put another way around, any given microservice is owned by exactly one team. So these teams own these particular microservices. And so we are in charge of that. Now, exactly how far you take that concept of ownership is sort of up to you. And a lot of people take that concept of ownership all the way into, I'm going to deploy and operate this actually in the production environment. There's still value here, even if you're still handing off to a separate operations department. There's still value actually in having this kind of strong ownership model. You become an expert in that area of your product domain. You're in charge of how this thing is changed. You have autonomy over decision-making. You can do whatever you want inside your service boundary as long as it continues to deliver the services it needs to the rest of the world. With a microservice architecture and an ownership structure aligned in this way, the kind of need for coordination between teams ends up being determined by how those services interface with one another. So we accept that some coordination is needed because ultimately we have to collaborate with our colleagues in some way to get things done. It's about limiting how much coordination we actually have to do. Now, there's a really good book called Think Like Amazon, which is kind of a distillation of a bunch of stuff that Amazon does. And it sort of plays back how Amazon think about this concept of what's called the two-pizza team, which for many has become the model of the modern microservice team. So this book's well worth a read. It's quite accessible. Here's a good quote from the book. The two-pizza team is autonomous. Interaction with other teams is limited. And when it does occur, is well documented and interfaces are clearly defined. It owns and is responsible for every aspect of the system. So there's a couple of things here. Firstly, the Amazon two-pizza team, the concept is you own the whole life cycle of that software, right? So they do go into a full, you own and operate this thing. But the interaction between one team and another team is defined by the service interfaces between those. One of the primary goals is to lower the communication overhead in organizations, including the number of meetings, coordination points, planning, testing, or releases. Teams that are more independent move faster. So we can reduce the need for coordination, work more in isolation, we can go faster and get the benefit of having more people, rather than what often happens is that people just add more and more people to a problem and you end up going slower. Another cracking book to read in this space, by the way, is a book called The Mythical Man Month, which must be nearly 40 years old now and talks exactly about this problem of coordination. We throw people at problems and we end up going slower. Organizations like Amazon have found out ways to get architecture and organizational structure aligned in a way to avoid that problem. Coming back to this idea of ownership, in this situation here, if I want to make a change to the accounts microservice, the only people that should ever care about that are the team that own the customer service up here, right? Because we share an interface point. Now, ideally, I make a change that is backwards compatible, in which case the upstream team doesn't care. But if I did need to make a change, I only now have to coordinate that change with one team. If I'm inside that world, if I'm a person that owns the account service, I know exactly which teams I need to coordinate with at any given point in time, because the teams I speak to are the teams my service speaks to or who speak to my service. And so you get this kind of, this nice sort of symbiotic relationship between these two things. Fundamentally, though, for this to work, you have to kind of get into really good at sort of maintaining backwards compatibility, right? So if you want this idea of independent deployability, maintaining backwards compatibility is key. And this is where a cutting edge idea for how you make this work, and this is a brand new idea that I want to share with you all the way from 1971. And that's an idea called information hiding, which basically says, hide your shit, right? No one needs to see the kind of horrific things that happen inside your microservice boundary or your module boundary. I mean, information hiding was about modular programming, but we don't need to see the detail. If we don't see the detail, maintaining backwards compatibility is much easier. If you've got a microservice and you allow you allow an external person to reach into your internal implementation detail, directly accessing your database, directly calling your code, then when you make changes, you've got a much higher chance of breaking compatibility. And that's going to be an issue when you now have to coordinate that change with an external team. This is going to slow you down. The concept of information hiding is really, really simple. Hide as much as possible inside your microservice boundary. Don't share anything with the outside world unless somebody externally needs it. The more you hide, the more you are free to make changes without affecting anybody else. You want to clearly distinguish between those things which are hidden, which obviously microservices includes our database, and those things which are shared. As a developer, if I touch anything in that shared world, I understand I've got to think carefully about maintaining compatibility, or else have a conversation with that external team about the change that we're going to make. But anything inside my hidden world is safe. And that, in a nutshell, is kind of what we're thinking about with microservices. They can enable for more autonomous organizations, but you've got to think carefully about how you find those boundaries. They're not a silver bullet. They come with a huge amount of costs. And I do want to really emphasize this last point. Microservices should not be a goal, right? Your customers do not care at all that you're using microservices. Your boss probably doesn't care at all that you're using microservices. You should adopt microservices only as a means to an end. What problem is it that you've got right now with your system architecture? What is it that you can't do with it? What change do you need to make to change your system architecture or the way you work to better serve your users, to better serve your internal or external customers? That's what you've got to think about. There are loads of people I speak to who are adopting microservices for reasons that are completely spurious. Like, why are you using microservices? I want to scale my application. Okay. Did you try running 10 copies of your existing monolith behind a load balancer? Because guess what? That might solve your scaling problem, and it's way simpler than a microservice migration. This idea that microservices have become the default systems architecture is deeply worrying, because we're almost in a space where years ago, I'm as old as Jamie, right? I remember a phrase where people used to say, you never get fired for buying IBM. And the idea was, because everybody else bought IBM software, if you made a decision to buy IBM software and it didn't work out, well, it couldn't be your fault, it's the industry's fault, right? So we would just do what everyone else did because we could avoid getting the blame. We're doing this now in microservices. Everyone's doing it without thinking about it. This should not be your default choice. You have a really, really good reason for adopting these kinds of architectures. And when I work with my clients, my default position is, you have to convince me as to why this is a good idea. Otherwise, I'm probably going to say no. Fundamentally, microservice enable team autonomy, right? That's one of the great things about them. But to make that happen, we've got to make sure that this sort of independent change is possible. I've got a little bit over my time, but we've got plenty of time for questions still. The second edition of Building Microservices is available in early access form, and there's a link over at my website. I think Carl's going to put a link in to my website in the chat. But that's it. I try not to swear too much, Jamie, but I hope that was kind of useful.
You've got the balance dead right there. You've dropped a couple of swears to keep it authentic without completely offending everybody. And it's already quite offensive to be confronted with a person from Hull at this time of the morning, right? I thought that was excellent, Sam. I've got a few questions about things like open source within the org, federated databases. But before I ask my questions, I'd like to see if anybody else would like to ask a question. So I know, for example, Tiago's been talking about liveness and readiness in the chat, but we've also had questions about how do we test this stuff? Is it just about chaos engineering? Is it about tooling? So if any brave soul would like to unmute themselves and ask a question, now would be a time. You can do it, audience. We believe in you. Okay. If nobody wants to do that, maybe we can ask that question directly to Sam. What about testing? What are we doing? Is it just about switching off containers that have got microservices in them, or is there something more elaborate?
I mean, well, firstly, that's an awful place to start. And this idea that chaos engineering is the be all and end all of testing is just nuts. So firstly, we should talk about, when we talk about the world of testing, what you're really trying to do is verify your software is of sufficient quality in a number of different attributes, right? And chaos engineering primarily is about understanding the robustness of your system. So that's only a subset of the testing world. You've also got does it functionally do what it's supposed to do? So, you've got to break the world down a little bit. So I think in Building Microservices, I talk about the different types of testing because you can distinguish between sort of load and latency testing, functional testing. You've got exploratory testing, your penetration testing. You've got, and then, chaos engineering is a niche of a niche, in my opinion. Okay, I don't want to get bogged down too much. And if people want to go deeper in that, they can. I work with a startup in this space, so I kind of know a little bit about what I'm talking about here. Testing at some level is easier, right? Because you can look at a microservice in isolation, you can test it in isolation, and that's great. So from a functional automated test point of view, you can think of it like testing a library. So normally what you would do is you would check your code in, you'd have a build pipeline for your microservice, you would run automated tests within that space. And then but the problem with that often is the biggest thing you're worried about is when I make a change to a microservice, I might break someone who uses it, right? So I'm worried about, am I going to make a change that breaks the consumers of my microservice? So you want a lot of the tests, that's where tests get really challenging in the microservice space. There's sort of three key ways you can fix that problem. One is to try and do end-to-end testing. And that's where you deploy multiple microservices together and run kind of some big test suites on it. Now, for a small number of microservices, like 2 or 3, that's fine. Those end-to-end tests don't really scale. They become really problematic if you're trying to do end-to-end tests across teams. So only ever do end-to-end testing within a team. You also, with end-to-end tests, they get quite expensive to write, quite expensive to run, and will have a lot of false negatives as your system becomes more distributed. Another option here is consumer-driven contract testing. Have a look at PACT. PACT as a library to help you do consumer-driven contract testing. There you basically get the consumers of your microservice to define how they think your microservice should behave, and then you run those tests. The other thing you should do is just, schema validation. Expose a schema from your microservice endpoints and validate that your schema changes are backwards compatible, right? That's really simple. All of the modern protocols out there allow for the definition with a formal schema, and you can do schema validation.
So in a way, Sam, we've moved back to proper software design and engineering, haven't we? APIs, yes. Contracts, backward compatibility. So Angus is saying he wants a bit more profanity. Well, fucking hell, Angus, I can tell you a story that will change your beard grey. When I became an engineer, Sam, or a professional, when I graduated from university, I loved building systems. And then all of a sudden, my whole life was XML and Java. And I was not happy. I was not a happy bunny. And Adrian Mort and I had met when we were studying distributed systems at Edinburgh. And now all of a sudden, real computing is back on the table. But I always say to people, this is hard. Distributed system building is really, really difficult. And I think that's what you're getting at here, Andy, with all these ranges of tests.
Well, there's also like two levels of complexity here, because there's the fundamental distributed systems a hard thing, and there's the other thing, which is that fundamentally microservices are a modular architecture. Right? Fundamentally, this is about creating an architecture where you have modules that can be worked on independently. And the way you go about making sure that those modules can be changed independently without causing breaking changes is about thinking carefully about the boundaries between these things and I think being explicit. So I'm a big fan. I'm happy to use a dynamically typed language, but I know that with statically typed languages, right, the compiler is going to pick up a whole bunch of errors that might otherwise have to be picked up with tests. It's no different with having a schema on your microservice. I think what happened is when people reacted strongly against the heavyweightness and the downsides of things like SOAP, is that they threw the baby out with the bathwater. They ditched XML for JSON. They got rid of schemas. And the reality is when you look at JSON now, people are putting stuff back into it. And it's like, really, there's no real difference now between JSON and XML, right? People say, oh, XML is way more verbose. So it's computers reading it, not human beings. It all compresses the same size.
Yeah, we used to use structured data, and then people would say, well, it's not human readable, and we were like, well, nav is this XML. Now, Sam, let's move on a little bit, because Carla's been filtering the questions, because we're getting stuff in now about different use cases where not to use microservices, and we've got questions about reliability. Carla, what have you got popping out of your chat box now?
I've got this one from Bala that is asking, in what all use cases microservices architecture doesn't fit?
Great question. I would say there's sort of two, I think, quite specific situations and one general one. Two specific situations where I rarely see microservices being justified. The first is when you're creating software that's going to be installed and managed by your end user. So think about where you're delivering on-prem software. The problem with microservice architectures is you push a lot of complexity into the operational space. Now, if you're running the software yourself, you can deal with those additional sources of complexity by adopting new tools, like Kubernetes as an example. But when you deliver software to a customer who's going to run it on their own infrastructure, you can't expect them to suddenly work out how to run a Kubernetes cluster. You go from delivering a DVD with an MSI on it and say, now, right, and the next release, here's 200 pods. Put this on your Kubernetes cluster, and they're going to go, what the hell's a pod? What's a Kubernetes and what's a cluster? So customer installed and managed software, I think you nearly always want to keep it very, very simple from a deployment topology point of view. Second choice is startups. I think microservices are a poor idea for most startups. And here I mean true startups, where you're a small team, you haven't yet found market fit. Small startups with no market fit right now have limited resources, and they don't know exactly what product they're going to build. So there's a danger that you get really in love with your idea. You think this idea is brilliant. If everyone does it, we're going to be really successful. If we're really successful, we're going to need a microservice architecture. Right. Well, because our idea is so good, let's build a microservice architecture now. And you end up spending your time building a distributed system before you've actually proved out your product. And then when you have proved out your product, you'll often find that the constraint in that initial design is totally different to what you actually end up needing. So I actually think a simple modular architecture, a modular monolith would be much better for the average startup. It will simplify your costs, reduces your infrastructure requirements. It allows you to focus on finding market fit. And then later on, you can say, oh, well, actually, it's this bit we want to spit out, or now we're throwing more people at it, and now we can spit it out. So, microservices are great for scale-ups. Once you've found your market fit, you've now taken on additional investment and you're growing. I think for that same reason, whenever you're building a brand new product, starting from microservices is challenging because you don't know exactly what problems you're going to get until you get them. And so again, and finding stable boundaries can be difficult in those spaces. So I hope that kind of makes sense.
I remember the genesis of Container Solutions can be traced back to when I did a huge job in my 20s for KLM, building their reservation pricing layer. And our services were small, but we were breaking them up and creating these APIs exactly as you would with microservices, because we had to save millions of concurrent users. The only reason we made those architectural choices because of the demand. As a startup, we'd have never have done that. We'd have had one jar file stuck on Tomcat, if indeed it was a web app.
But in that situation, like, you've got information and understanding about how the system is working, where the current constraints are. So for existing orgs that are maybe migrating to microservice architecture, they've got an understanding of the product. That's a very different space. I think Jeff Dean from Google, I think I can't get the quote exactly right, but he sort of says you can normally take an existing architecture and tweak it to get 10x scale, but you're going to have to rebuild it for 100x scale.
Absolutely.
And that's the sort of space we're into here.
I think that's a good heuristic, isn't it? If you want to go 10x, just, incremental improvements. If you want to go 100x, you need something different. Now, we've got a good question. We've got a few good questions, actually, Sam. Although I don't know if you want this one. What about transactions across multiple microservices?
Okay, so
is that a thing? That's the question. How do you tackle it?
I mean, it is a thing. Someone asked me the question yesterday, in fact, how do I deal with the pain of distributed transactions? And I always said it's like how you deal with the pain of punching yourself in the face. Just don't punch yourself in the face, right? Distributed transactions are, in general, not a great idea as a general purpose solution for coordinating the activities of multiple microservices. They are deeply problematic for a number of reasons. One of those issues is just fundamentally you end up coordinating locks, and that's a problem. So there are other ways of solving issues. Not what people normally want out of when they go from a transaction in a single process system, you get these lovely kind of atomic properties.
Yeah.
You don't actually, when you start looking at the distributed transaction algorithms, get true atomicity in the way you think anyway. So don't do it, don't do it, don't do it, please don't do it, please don't do it. If you really need to get multiple microservices collaborating with one another, that's totally fine. There are other ways of doing this. So the first thing you can do is look at these things called this concept called sagas, which kind of talks about how you explicitly model interactions between multiple microservices. Underneath that, you've kind of got two banners, two implementation styles of sagas. One's called orchestration, and the other's called choreography. You can read about these, I think, in one of my books, probably. Yes, you can. I talk about this stuff in
So when you say don't do it, Sam, don't do it, you actually mean don't fucking do it.
Yes. Now, there's one exception to this, which is that the smaller the scope of the distributed transaction, the less problematic they become. But I would be using those in a limited space. And an example of where I would use it would be something like within a service boundary, I'm putting something into a database while I also pop something on, say, a message broker topic or a queue. I might be inclined to use a distributed transaction at that level. I'm keeping it within the scope of a single microservice boundary. I've got a limited number of moving parts, and I'm often talking to subsystems which have high availability. So some of those issues are much more sidestepped. But yeah, now, just don't do it.
Now we've got a good question emerging, and this might actually cover many people's concerns. It's more of an organizational question, actually. As your microservices, as your business changes and evolves, the boundaries of your microservices might evolve too. How do you redefine or refactor the boundaries along the way?
So you've got some different options. One of the things is recognizing that you will change your mind. And so giving yourself space where you can change your mind in a way that doesn't affect people. So one example of that is if you've got a team that's got they own some piece of the functionality of the system, and they decide to break that apart into 15 different microservices, and then they decide to merge some of those back together again, that can be quite disruptive to the rest of the organization. So in that situation, you might be tempted to say, well, actually, this part of the organization, our team handles all finance related stuff. Well, we're just going to present to the outside world a finance API. Behind the scenes, we've broken that apart into 5, 10, 15, 20 different microservices. We change our mind, we merge them back together again. We moved ownership of one of these things to a separate team. But the people calling that finance API, they never even needed to know. That's sort of like information hiding at an organizational level. In terms of organizational structures changing, you can just obviously sometimes, if the boundaries themselves haven't changed, you can just reassign ownership. And you will get situations where like a lot of your microservices are like, well, this is 100% ours. That's definitely yours. And you get these ones that are a bit in the gray area. Well, it could be ours, it could be yours. If you can but there's no real problem with just temporarily reassigning ownership of those microservice boundaries. If you do get into situations where ultimately you are needing to make sort of backwards incompatible changes to your service interfaces, that does happen. In those situations, remember, we still want this property of independent deployability. So if I'm going to change the boundary of my microservice, I don't want to immediately say that everyone that calls my microservice has to update at the same time because we're into the world of lockstep releases. So what you would do there is you just need to coexist both the old interface and the new interface at the same time. And you might do that for, say, a few months or whatever, however it takes to get people migrated. You monitor who's using both interfaces. Once the last person has stopped using the old one, you can retire that old service interface. And the best way to do that normally is to have one microservice exposing both the old and the new interface. And that will drastically simplify a lot of your kind of infrastructural and operational concerns.
That's a great answer, Sam. I remember speaking to somebody from Skyscanner, Stuart, good dude. He was talking at a conference, and he was talking about this. And at one point, it's an organizational issue, and you start doing all hands, and you mention new changes, the old microservices being retired, and then start to incentivize the organization, and eventually saying, right, this is going to be switched off in August. Make sure you're consuming the new. So it's where the technical meets the organizational.
Yes, one of the big things is stopping people calling the old endpoint. Yeah. And so I know SoundCloud, like at Skyscanner, SoundCloud, they said we should turn it off after 12 months. Yeah. We don't even care if anyone's using it. If you're still using it after 12 months and we turn it off and it causes your system to break, it's now your problem. I did see a great presentation. I can't remember the person it was now. And they couldn't stop people calling this old code path. And so the way they dealt with that was they did all the good stuff and then they just inserted a sleep in the code and they just increased the sleep. So when you were calling the old interface, it just started getting slower and slower and slower. And eventually everyone worked out they shouldn't be calling that endpoint anymore and gave up. But you've got that's like a social contract. Yeah. Right? You have to have that agreement in place and explanation about what you're doing. The key thing here, though, is from a coordination point of view, if that change is happening, I don't have to have an all hands. The only people I need to talk to are the people that call my service. And that might be 2 or 3 teams, not 200 or 300 people. So if you can limit those coordination points, that also becomes much less of an issue.
Well, I know, I mean, that Container Solutions, Sam, we're often the bearer of bad news. People call us because they want 3 containers and a slice of Kubernetes. And we tell them you're not going to succeed if your organizational changes or your organization doesn't support large-scale distributed development. But it's true, it's as much about the social work as it is about technical stuff. Now, moving along, we've got a few more questions here. Okay, I think this is a very specific one, but I think it needs to be asked. Maybe somebody's a bit frustrated right now. How do you get out of the hole that you're in because somebody's already done those don't do these things?
I mean, so I am available for consultancy. I think the problem is whenever you're in an environment where someone's done something that you don't like and you think things should be done better, it's very easy to straight away get into a situation where you're arguing over detail, you're arguing over the activity, you're having a VI Emacs conversation or a tabs versus spaces conversation. In these situations, I always try and put it up a level. Rather than saying we shouldn't have split that, right? That's like you're saying what you did was bad. What you instead first want to do with that person or those people is to make sure that you're both on the same page as to the outcome you want. We both want to be able to ship code quickly, don't we? Yeah, we do. Okay, we both want to be able, so you want to be able to do your work, I want to be able to do my work. Yeah, that's what we would like to do, yeah. Okay, so one of the challenges at the moment is we're sharing a database and that's causing us an issue. But because we want the same outcome, maybe we're at least on the same page about where we want to get to, and then you're only having the conversation about how you make that happen. But if you just go, we shouldn't share databases, what you did was bad, even if you don't say that last bit, what you did was bad, it's what people hear when you say, this is the bad thing to do. So always in these situations, get on the same page about the outcomes that you are both trying to achieve. And then it's easier to have conversations about the detail. Sometimes in those situations, you realize they've got a whole different set of worries. There's a whole different set of problems that they're trying to solve that you had never considered. Another nice little technique that can work, I think, at the team level where you get like disagreements. It's like an old tech lead it was my tech lead at The Guardian was a guy called Eric Dernenberg, and he had this great technique when developers wouldn't agree. And back then at ThoughtWorks, right, especially, you'd get 2 people in a room, you'd have 3 conflicting opinions. That's just how that organization worked. So he would get 2 developers and get them to switch around their ideas. So if you were like pro VI and I'm pro Emacs, we would have to instead advocate for the opposite of what we wanted. And he said, go away, you're advocating for Emacs, you're advocating for VI, come back and have a debate. And a lot of that was about just creating a situation where you force yourself to actually be in the other person's shoes for a little bit, to build some empathy for their position. And then you might often realize that actually, no, I was wrong, or there's some middle ground. So I hope that, that's kind of the things. Yeah. Plus, buying lots of copies of my book, and then you can kind of wall in the people that don't agree with you. You need like a couple 100 copies, I reckon.
We could come back to some of these topics in a follow-up, of course, and do more deep dives. Now, Sam, I think we've got, let's see if people are still here. Where's my, well, we've still got 90 people here. So some people have said goodbye because they've got other meetings. Now, typically when people are still here, it means that the conversation's going well and people care about what you're saying. Now, I'll ask again, has anybody got a question that they'd like to actually ask? Face to face, unmuted, with your camera on. Because my job is to engage the audience. And Sam, you're such a large character and you're on the spectrum between human and caveman. So you might have silenced the audience.
In addition to you. I mean, we could also just talk about State of Origin yesterday, if you wanted to. Yeah.
Loud?
Caveman spectrum.
I'm probably too much on the caveman spectrum. But...
Oh, no, there you are. You are. Okay, you're doing well, Matt.
Welcome back. Hello, coming in.
Bit curated, my beard. I'd just like to ask Sam, well, first of all, thank you for brilliant talk and brilliant answers to the questions. How are you feeling about service meshes, whether they're a help or a hindrance towards getting people on the microservices journey?
Conceptually, good idea, right? Which is, how do I share common connection-oriented functionality in a way that I don't have to bake it into my program, but also don't have all the downsides of kind of separate proxies, right? In terms of, separate machine proxies. So conceptually, I think the idea is really good. I think the challenge is the maturity of the implementations. I've been giving the same advice for nearly 3.5 years now, which is, if you can wait 6 months before picking a service mesh, you might want to wait 6 months. I mean, look, we've had a lot of churn in this space, and although the models have stabilized around currently the sort of sidecar implementation and demonized local proxies and things, using Envoy or whatever else, it's still taken a long time for that to happen. I mean, Istio took like 2 years to get to 1.0, and even after 1.0, there were some fundamental re-architectings, and I think they're the right things to happen. So conceptually, I think the idea is great. I think it's just, my only question has ever been, is the quality of the implementations. The organizations I think that are right for using service meshes right now, if you're operating at scale, right? Because if you've got more people, more teams, you want a degree of consistency in terms of how common connection concerns are handled. Like being able to handle things like mutual TLS as one example in a central manner is really, really great offload worry. It's also, even if you weren't a massive team or larger organization, it's still also definitely worth looking at if you've got a large mix of technology stacks. So where you don't have the possibility of sharing library code. So like if I've got, say, JVM processes talking to Python apps or something, I'm more likely going to look at them. So conceptually great, but still there seems to be a bit of churn and there's still some things to be shaped out in that area. So I think if you're going to, it's nowhere near as bad as it was. You could probably pick Istio and it's probably going to be fine if you're ordering Kubernetes. But I certainly spoke to some people early on. I mean, Monzo would be a great example. Like Monzo have said they couldn't do what they did without a service mesh, but they've gone through at least 2 iterations on what service mesh they're using now. So I think it's slowing down. It's stabilizing more. Conceptually great. Quality of the implementations. So I think if you don't need it right now, wait. If you do need it, just go cautiously and maybe don't push too much into the service mesh too quickly.
It's funny that you bring up Monzo there, Sam, because obviously great company. Starling Bank have also spoken at some of our events. These people take technology seriously and their executives understand this. And one of the things that pops up in our patterns book is that without an existential threat or a real reason to do this, you'll never be able to do it. So that's certainly something I think in regard to that question. What does the management support look like and how seriously we're taking this? Because as you said, it's a consistently iterative and experimental process.
Yeah, and there is that general thing, which is in this space of microservices as a whole, there is so much buzz around technology. In a way, it's like where the JavaScript ecosystem was maybe 5-10 years ago, right? It's a constant race to keep on board with a new technology and understand and assess what works for you. One of the biggest pitfalls I've found with the larger organizations is that before they even really start to get into grips with what microservices might look like for them, they try and solve these problems up front. They go and say, we're going to be running OpenShift with Istio built on top. We're going to use this technology and that technology and that technology. And then when they actually try and use it, they realize it doesn't quite fit their needs, or there's some corner cases they hadn't considered, and they've just created a big heavyweight stack. There's a Mike Tyson quote, which is, everyone has a plan until they get punched in the face. And so I think like a lot of like these big kind of organizational microservice transformation efforts, which are like, let's get a giant stack of stuff and then try and use it. You spend all your time on the plan, and then you actually try and put that plan into action. Like, just create one microservice doing what you do today. Just one. Don't change anything. Use the same programming language. Deploy stuff manually if you have to for the first thing. See what happens. Work out what was not good, and then bring in the new technology as appropriate to see, if you can improve it. There's a danger that you front load too much technology acquisition. That just drastically increases the cognitive load, right? You're already going to have to fundamentally get to grips with what the hell distributed systems are. Doing that at the same time as changing your programming language and Kubernetes and service meshes, that can be a bit too much for your first day.
Now, Sam, let's just cycle back to Matt and see if that's answered his question. Matt, is that good enough for you?
Very much so. Yeah, I mean, it reflects kind of what I've been seeing when you end up with a transformation where someone's like, oh, we need to do microservices. Oh, well, let's have some people, they can go and install Istio, get it all working. And then there you go, there's your microservices platform, whilst not addressing things like the boundaries that you need to make sure are correct in the organizational structure of the teams. So yeah, that's kind of what I was thinking. So I'm quite glad. I could be a bit smug, but that was a brilliant answer. Thank you, Sam.
It's always good when you get an answer that, that's sometimes webinars are good about just confirming that you're actually on the right path. But I feel sorry for the people when they find out they're not on the right path, and the colour sort of drains out of their face. Now, anybody else want to unmute themselves, say hello? We're going to be running these webinars like regularly, so if regular guests, you might as well get used to speaking. Hello? No, that's also fine. A lot of abuse about Istio in the team. I don't think we need to come back on that per se.
Is that directed to me or directed towards Istio?
No, it's like Istio. Oh, Istio's a nightmare. And I promised not to sell, but I put a training course in there that we do.
Well, it's
sorry.
Okay, go ahead.
I wanted to say something. I saw Richard unmuted himself.
Oh, Rich.
Yeah, hi.
Hiya. Coming in, mate. Thank you.
Hi, Sam. Hi, Jamie.
Hi.
I was interested in your thoughts around particularly team topologies, because it seems to sit very nice as a way of kind of solving a lot of the social problems around microservices and the kind of right approach. What are your thoughts on it?
So I'm biased a little bit because I consider both Matthew and Manuel to be friends. I've known Matthew for years, and like we first crossed paths. Interesting, I said I got into microservices because I was doing continuous delivery work. That was my focus for like the first 5 years, from 2005, 2010. And that's where I first met Matthew. We both come from being really interested in the same areas. We just he went the organizational kind of change route and I went this other route. I mean, microservices are, another James Lewis quote, microservices are an architecture which optimizes for autonomy. There's a danger if you adopt all microservices, but don't do the organizational stuff, that you'll pay a lot of the cost without getting as much of the benefit. So I think the ideas behind team topologies there's some great stuff in here. And I think what they've done with the book is give us sort of a shared sort of set of terms around the different types of teams to help us put words around some of these ideas, because the whole concept of the two pizza team is a bit vague. And, I love the fact they go into detail talking about like enabling teams and platform teams and those roles that they play. So for me, it's like these ideas go together incredibly, incredibly well.
It almost felt like a playbook of this is how to actually implement microservices. If you don't use this, you're probably going to go wrong somewhere. But that was my opinion of it. So it's good to hear outside.
There's other good supporting stuff as well that I'd consider. Emily's got an awesome book on how you create communities of practice. I'm really embarrassed to say that I've forgotten Emily's surname. I'm going to look it up. So there was other really excellent work out there in terms of how you actually put these plans into action. So I think that's really nice. I mean, that is, this talks about the different types of shifts you need to make as well. I mean, fundamentally, I think we're still, as an industry, still kind of trying to get our heads around the idea that we can't just copy a paper around how Spotify once did software development back in 2012 and just assume that's going to work for us. And we're still dealing with that. It's like, The
nicest thing is, Sam, the nicest thing about all of these changes are we take this seriously or we instantly fail. So if you're properly into computing, it's an awesome time to be alive.
Yes, absolutely.
Now, just to come back to Richard, because you've mentioned team topologies, you probably know that Matthew will be the next guest with me here on the webinars, and it will be about team topologies.
Oh, what?
Did you know that?
I knew he had one coming up. I honestly hadn't put two and two together, but I was planning on attending.
All right. Okay. So basically, the cloud native transformation pattern, just not to steal your thunder, Sam, because I know it's more about what we're doing with microservices. Cloud Native Transformation Patterns, our book, is often read with team topologies. And customers, they use our book to build the strategy, and they take the stuff from team topologies to keep the fast flow going. And it's become a thing now where they bought, oh, thank you, Sam. Thank you so much. Team topologies and Cloud Native Transformation goes together, and of course with Sam's book, and it's a playbook for modern Cloud Native Transformation. So that's exactly what me and Matt will, Matthew, I should say. He doesn't like being called Matt. This is what me and Matthew will be getting into. How do the worlds overlap? Matthew is also a Northerner, by the way. You know, so that gives him 5% more credibility than Southerners like Sam. You know, it's difficult.
Yeah, but I like rugby league, so I get that 5%. I get that 5% back.
That is true. That is true. We do like your league. Okay. Any more questions, Richard? Are you happy with those answers there?
Yeah. No. That's great. Thank you. I'm looking forward to the upcoming events.
Wonderful. Okay, and are you?
Oh, and just sorry to interrupt, Jamie. I've just put a link to Emily's book in the group chat. So it's Emily Webber. She's awesome, and her book was Building Successful Communities of Practice. She could be a great person for you to chat to, Jamie. By the way, she's got some great talks out there as well. So she's really worth chatting to. But the book is great, and I know Matthew also recommends that book as a way of kind of helping build those supporting communities within these sort of organizational shifts. Yeah.
Now we've done a pretty good job to keep 80 guests busy for over an hour now, and usually, you know, you've had a shit webinar when people just start dropping off. This is like a proper leading indicator. I think we should probably wrap this up because people's concentration will be at the end. Are there any more questions or burning things people would like to say? I think now will be the time for one final comment or question.
Sorry, I've got one. I just wondered about when you get to a more mature microservice type environment and you've got lots of services that collaborate with each other, that kind of implies dependency. And I just wondered kind of if there's any kind of recommendations how you catalog those collaborations or dependencies, whatever you want to call them.
Yeah, I mean, there's a couple of things. I mean, firstly, it's, you know, ideally you're limiting these endpoints to the point where you could probably hold them in your head in terms of, I know we talk to these things, but as you get more fine-grained, that does become more challenging. Most of the organizations that I've worked with that have got beyond the, I've got 5 or 10 microservices, and it's actually a ratio thing, by the way. What I find is it's a balance between the number of, you know, it's the number of microservices per developer. Like when you've got like 10 developers for every microservice you've got, it's very easy for the organization collectively to hold those relationships in their heads, more or less. When you start getting to a place where you've got like 5 microservices for every developer, right, which is at the other end of the spectrum, you absolutely start starting to need tooling. So it's not going to be a day one thing. But what you tend to see is that organizations end up creating their own kind of internal registries. So SoundCloud did this, for example, by putting little simple JSON files in the roots of their the source code repos, and a little program that would pull that together. So they would define their SLOs in those JSON files as well, and which services they communicate with. And then you can kind of build it up into a picture of like, here's me, here's what I talk to. Of course, you can also do that in runtime programmatically. If you've got, if you're putting out runtime information about your outbound and inbound endpoints, you can also do some of that programmatically in the system and kind of merge that data together. Another great example of a company that's talked about this publicly would be the Financial Times. So the Financial Times have been using microservices for a number of years. They've got teams all over the world. Sarah Wells has done a really nice talk at QCon London, I think it was this year, about sort of mature microservices and how to operate them, it was called. I'll try and find the link for that for you to put it in the chat. And Sarah there talks about the tool they've got called BizOps. So they've actually created a tool internally, which is like their internal service registry. Again, it works in the same way. You put a JSON file in your source code repo. They just go through and poll all those things together. With BizOps, they've gone beyond just this is my service, this is where it is, into actually doing like automatic checks that they're behaving in the right way, that they're doing the right things. And they've actually extended that idea beyond microservices to cover other kinds of sort of IT infrastructural parts of their system. I mean, look, again, you know, using old fashioned terms, you could argue that this stuff is a CMDB done well, you know, which kind of you could say that if you want to. But yeah, if you want to do search, so if you dig out a talk by Sarah Wells, look for a tool called BizOps mentioned. It's not open sourced. The problem with a lot of these tools is that they haven't been open source because they're often so baked into how that particular organization does software development. I would be surprised if we didn't see startups in this space, to be honest with you, at some point. But I hope that helps.
Now, there is actually quite a few questions, but I think we're going to close this down now for 2 reasons. We're not going to finish on time. And I think, Sam, we've consumed a lot of your energy and a lot of your insights. Just to remind people, you can send me an email or join our Slack channel, which is open to the public, if you've got any further questions, and we can either answer them as CSs, or I can nudge Sam to see if he can point you in the right direction. I think we should all give Sam a round of applause, which I'm going to start now. I mean, Sam, you were, without a doubt, a consummate professional, one of the best public speakers and educators in our community. Every time you speak, that's completely obvious to me, and I think many other people who join these webinars. To the rest of you, you all said you loved it. That's great. So next time, bring some of your teammates with you. Share some stuff on Twitch if you like. I don't give a fuck, but my marketing team will give me thumbs up on Slack. I'm kind of their boss, and so I've got to encourage them and stuff like that. I say this all the time at CS, but I've never said it publicly. I'll say it now. I love you all. I'm so happy to be part of this community and leading this business. Yeah, thank you again. Sam, any parting words?
No. Well, thanks for having me. Thanks for all the great questions, and maybe I'll get to speak to you again in some further format in the future. But yeah, thanks for the great questions.
I think so, and thank you for being on the very first Container Solutions What the ckInars, Sam. It's historical. Okay, ladies and gentlemen, boys and girls, see you later. Bye.
Bye.